Hey y'all, so in this lesson, we're going to learn about velocity, acceleration, and forces. So our deck summary is today you will learn what velocity, acceleration, and forces are, and how to apply it to real-life word problems. So our skills acquired is you will learn how to calculate speed, distance, and time. You will learn how to use the equation from speed, distance, and time in real-life word problems. You will learn what velocity is and how it relates to speed. You will understand what acceleration means, and you will understand how to use that to identify whether objects are actually accelerating. You will learn what balanced and unbalanced forces are and how to identify each one. And you will also learn what net forces are and how to calculate them. So the definitions we're going to need for this lesson. First is rate, which is a ratio between two related quantities in different units. Speed is the rate at which something is moving. Speed is the absolute value of velocity. Velocity is speed in a given direction. Acceleration is the increase in rate of speed. Mass is the measure of the amount of matter in an object. And a force is a push or pull on an object that is caused by its interaction with another object. Notice that I bolded some of the most important words in each definition. So first we learn what speed, distance, and time are and how to use that in an equation. So how do we calculate speed when we are given both the distance and time? How do we calculate time when you're given speed and distance, or distance when you're given time and speed? It's pretty simple. You have to remember one form of the equation. Then we need to know how to manipulate that one form of the equation for what you need to find. So the natural equation for speed, distance, time is speed is equal to distance divided by time. We have to learn how to derive the other equations from this equation. Derive means to get something from something else. You're going to see this word often in math. So if S is equal to d divided by t, speed is equal to distance divided by time. We have to solve for t, and then we solve for d. So on the left-hand side picture, we're solving for time. So we are given S is equal to distance divided by time. We have to multiply by time to cancel it out on the right-hand side. So then we end up with speed times time is equal to distance. Then we have to divide by speed to get time alone, the variable for time alone, on the left-hand side. So then we get t is equal to distance divided by speed. In the right-hand side picture, we have speed is equal to distance divided by time. We have to multiply by time to cancel it out on the right-hand side of the equation. So then we get speed times time is equal to distance. So that is the equation for distance. So some word problems to practice. There is a train on its way to Buffalo, New York from Hartford, Connecticut. It is traveling at a constant speed of 200 meters per second. The distance from Hartford to Buffalo is 720,000 meters. How long will it take the train to get to Buffalo in hours? Round to the whole number. So we know that the speed is equal to 200 meters per second. We know that the distance is equal to 720,000 meters, and we don't know what the time is equal to. So if we're solving for time, think back to the last slide. T is equal to distance over speed. So this is our answer. So I help you solve it. T is equal to distance divided by speed. T would then equal to, because our distance is 720,000 meters, our denominator will be the speed, which is 200 meters per second. So we can do some long division, or you can do it on your calculator. That brings us to 3,600 seconds. But the word problem in the last slide asked for it in hours. So we need to know that 60 seconds is in 1 minute and 60 minutes is in 1 hour. So 3,600 seconds is in 1 hour. So the train will reach Buffalo, New York in 1 hour. So you can try one on your own. I highly suggest pausing the video and doing it by yourself. But if you want, I will give you a head start. Sorry. Speed. So Jackson is driving his new car to his friend's house at a constant speed. He reaches a red light, and at that point, he traveled 36,000 meters. He's been driving for about 30 minutes. What was his speed before he reached the red light in meters per second? So we don't know what speed is, but we know that distance is equal to 36,000 meters, and we know that the time is 30 minutes. So you can pause the video and do it on your own. If not, I have the answer. We have the equation speed is equal to distance divided by time. So we know that 60 seconds is in 1 minute, and so that means that 1800 seconds is in 30 minutes. Because you need to, 1 minute to 30 minutes, you multiply by 30. So 60 seconds times 30 is equal to 1800 seconds. So our speed is going to be 36,000 meters divided by 1800 seconds, which brings us to 20. So our speed is going to be 20 meters per second. Don't forget your units in these word problems. So now we learn about velocity and the difference between velocity and speed. So essentially, velocity is speed, but with a little twist. So note that on the left-hand side picture, that the car is driving in just one direction. Let's call it west. But in the right-hand side picture, this car is driving in two different directions. First, it's going north, and then it turns to go east. But in the right-hand side picture, it's still driving at a constant speed. So the difference between velocity is that velocity means speed in one given direction, and then the second one, speed, is just a constant rate. It doesn't really matter what direction you're driving in. So the word problem will ask you what is the speed and what is the velocity. So you won't really have to differentiate on your own. But sometimes word problems will ask you for both, in which case you need to know the relationship between the two. So now we learn about acceleration. So earlier, acceleration was defined as an increase in the rate of speed. Well, what does this mean? An increase simply means going from a smaller number to a larger number. Acceleration is the same thing, but in terms of speed. So a car that is driving at 30 meters per second and increases the speed to 60 meters per second is accelerating because the speed goes from 30 to 60. One thing to note is that once the car reaches 60 meters per second and stays at that speed, it is no longer accelerating. This is because now it is constant at 60 meters per second. It is no longer increasing in its speed. So determining acceleration. You can use this link to help you get practice on it. It's a great link on ixl.com. Next, we learn about forces. So force is a broad concept encompassed by Newton's laws. Newton's laws are based off of Isaac Newton, who was an English physicist and a mathematician known for his laws of physics. But right now, we are going to focus on Newton's second law. So Newton's second law is force, which is in a very unique unit called newtons. Force is equal to mass, which is in grams, times acceleration, which is meters per second squared. So highlighted in blue is the units for force called newtons. It's obviously named after Isaac Newton. So now we learn about the relationship between force, mass, and acceleration. So the equation is F is equal to ma. Force is equal to mass times acceleration. So imagine that the force on an object is constant and the acceleration of an object doubles. What would have to happen to the mass of the object to keep the force the same? So if the force is constant but the acceleration doubles, we need to know that the mass of the object would have to be cut in half, because 2 times 1/2 is equal to 1. So if the acceleration doubles, the mass would have to be cut in half for the force to stay the same. So imagine that the force on an object is constant and the mass of an object doubles. What would have to happen to the acceleration of the object to keep the force the same? Well, it's the same thing. Mass and acceleration are being multiplied and force has to stay the same. So if the mass of the object doubles, the acceleration would have to be cut in half for force to remain constant. So the next one is, imagine that the force is changing. The force doubles and the acceleration of an object stays the same. What would have to happen to the mass? Well, if the acceleration stays the same, but the force doubles, that means 2 times 1 would have to equal 2. So that means that the mass has to double. So the next one is, imagine that the force on an object doubles, but the acceleration this time is doubling. What would have to happen to the mass of the object? Well, if the acceleration is already doubling, which accounts for the force that is doubling, the mass would have to stay the same. So next is balanced and unbalanced forces. So there is a block, but first, net force is the sum of all forces acting on an object. If there is a net force present, the object is accelerating. That means an increase in speed. So we have a block and we have 2 sides where there is force being put on the block. On the left-hand side, we have 5 newtons of force, but on the right-hand side, we have 10 newtons of force. So we know that 5 newtons plus a negative 10 newtons is equal to a negative 5 newtons. This essentially means that if you're pushing the block to the right with 5 newtons of force, but then there's another person pushing the block to the left with 10 newtons of force, you know that the 10 is greater than 5, so it's going to go to the left with 5 newtons of force. So this means that the object has a net force of 5 newtons and it will have to move to the left because the right-hand side force, which is pushing it to the left, is greater than the left-hand side force that is pushing it to the right. So these are called unbalanced forces. This is because 5 newtons is obviously not equal to 10 newtons. So on this one, we have on the left-hand side, which is pushing the block to the right, we have 10 newtons of force. But on the right-hand side, pushing the block to the left, we also have 10 newtons of force. So because one person is pushing the block to the right with 10 newtons plus the person pushing the block to the left with a negative 10 newtons, you get 0 newtons. This means that these are balanced forces because there is no net force, or the net force is equal to 0 newtons. This is because both people on both sides of the blocks who is pushing the block in opposite directions with the same amount of force will not move it anywhere because it is the same amount of force. There's no one person pushing the block with more force than the other. They're both equal. So some word problems. A car has a mass of 700 grams. The car accelerates at 50 meters per second squared. What is the force of the car? Well, we know that the force is equal to mass times acceleration. So we have to keep that equation in mind. And so that would mean that F is equal to 700 grams times 50 meters per second squared. So that means that we get a total of 35,000 newtons of force. So here's some more practice. These are great links for forces and unbalanced forces and balanced forces. So more resources would go to these worksheets. They're great practice. Hi, my name is Tavisha Goyle and I'm 16 years old. I'm a junior in high school and I live in Florida. Thanks.